When we're looking for exact values of trig functions, these are not ones that you can just punch in the calculator and see what you get and round it to a few decimal places. As soon as we start rounding, it's not an exact value anymore. It's a decimal approximation. I want exact values here, which means unit circle. So the secant of 330 degrees. The first urgent question is, where's 330 degrees? Well, 330 degrees is definitely more than 270, but it's not as much as 360, so I don't make it all the way around. I'm going to end in quadrant 4. Using a reference angle, I'm going to draw my triangle. Using the x-axis, there's my little right triangle. The reference triangle is the one that's inside the triangle. In quadrant 4, we can find reference angles by subtracting 360 minus the actual angle. So my reference angle here is 30 degrees, and I'm a third of the way there. Next thing I want to do is see if I can figure out what the secant of 30 degrees is, because all the trig functions of 330 degrees are going to be the same as the trig functions of the reference angle. I know the secant is 1 over the cosine. The cosine of 30 degrees, oh heaven forbid, I used the wrong color, can't have that. The cosine, there we go, of 30 degrees is root 3 over 2. The secant is its reciprocal, so that means the secant of 30 degrees is 2 over root 3. If it bothers you, you can rationalize that and get 2 root 3 over 3. I'm not going to. You don't have to. I trust that you could if you felt like it, so you don't have to. So the secant of 330 degrees is 2 root 3, either positive or negative. So that's the last piece of the puzzle here. I got to figure out, is it positive or negative? Here's where we are so far. I'm going to leave some space in case I need a negative sign. And to determine that, we know the signs in the quadrants. In quadrant 1, everybody's positive. In quadrant 2, sines. In quadrant 3, tangents. In quadrant 4, cosines. Oh, well, we're in quadrant 4, where cosines and secants are positive. So we'll need positive 2 over root 3, which means we did it. And there's the secant of 330 degrees. Next, I'm looking for cosecant of 5 pi over 4. So again, we need to know where that is. Well, 5 pi over 4, halfway around is pi, which is 4 pi over 4. 5 pi over 4 then is going to be in quadrant 3. I'm going to draw my reference triangle. There it is. My reference angle is the one that's inside the triangle. In quadrant 3, I can find reference angles by taking my original angle and subtracting 180 degrees or pi. 5/4 minus 1 is 1/4, so I got pi over 4 as my reference angle. So all the trig functions of 5 pi over 4 are the same as the trig functions of pi over 4, possibly except for the positive or negative sign. Well, let's see. The cosecant is the reciprocal of the sine. The sine of pi over 4, that's the y value from the unit circle, is root 2 over 2. The cosecant is its reciprocal, which is root 2. It is 2 over root 2, but that simplifies to root 2, which is significantly simpler. So that's just going to be easier to work with if we call it root 2. So here's where I am so far. Cosecant 5 pi over 4 is either positive root 2 or negative root 2. We just got to look and see about the sign. All students take calculus. In quadrant 3, tangents and cotangents are positive, which means cosecants are negative. And we got it.